take. All writing is persuasive writing. Whether you're composing an argumentative essay, a short story, or a scientific article, your goal is to evoke a desired response from your readers, guide them toward a particular conclusion. In other words, you're constructing an argument that will persuade your audience to see the world in a certain way. Science is fundamentally about deciphering the relationships between things. And scientists construct arguments to help themselves and others understand precisely how their observations are related to their conclusions. Cold take. Cryoseismology, the study of icequakes, is the coolest. In this episode, real-life ice princess Dr. Celeste Labedz shares her work with the Juneau Icefield Research Program in Alaska. She explains why ice is so special and important, telling us how she measures the behavior of ice in glaciers to draw important conclusions about climate change. I'm Jocelyn, and let's get verbing.
A lot of cryoseismology's goal right now is to provide improved ways of looking at what's going on in a glacier system or in an ice sheet system or in permafrost or whatever. We need more tools, especially in a changing climate where a lot of these systems are undergoing some wild, unexpected changes. Having more tools to be able to observe them well is really, really helpful to get a more full understanding. And so you can detect seismic signals that come from deep within a glacier in flowing water going underneath a glacier or in sliding happening at the bed. And those are things that you can't see with your eyes. Now, there are a lot of other tools that we can use to look inside of glaciers too. You can use radar to sort of take like an X-ray slice of a glacier and maybe see what its shape is, or you can drill boreholes into a glacier. And stuff like that together with cryoseismology can really help get a more complete picture of what's going on there. So it's a cool observational tool that can tell us a little bit about either the source of those icequakes, of those seismic waves, or it can tell us about the structure of the glacier as well.
And it's non-invasive, I guess you could say,
yeah,
right?
We don't have to drill into it.
Right. And so you're able to infer from what you observe, what you can't observe directly or aren't observing directly.
Yeah, and it's a lot easier, too, to just set a seismometer next to a glacier rather than having to get a big drill onto the ice and then drill down. Although they're telling you different things, and sometimes you still need to. You can get the best info from a borehole. But it's really handy if you can just drop a seismometer and then leave it be. They don't need much babysitting if they have a solar panel and stuff like that. And then you can get lots of really cool info from it.
Is this kind of an exciting time to be a cryoseismologist, just with climate change and ice is melting and a lot of changes going on with the climate and everything?
Yeah, it's an interesting time to be working in.
Maybe not exciting.
Yeah,
I meant that in a way in which, it's actually like existentially we're all dreading time, but at the same time, it's like you're getting a lot of data of like movements and
Yeah, so it really, working in cryospheric sciences, any kind of investigating our polar world and anything cold is very interesting to do right now in the age of climate change. And really seeing the effects of climate change really reiterates the importance of doing that research because stuff like glaciers and how they melt, how fast they're going to melt, how much mass they're going to lose, at what rate, is really important for determining not only stuff like sea level rise, but also glacier meltwater. Regular old glacier meltwater is a stable source of drinking water and water for agriculture, and it's a major water source for a lot of people in the world. So lots of folks in places like India and China are relying on glacial meltwater as a really good stable melt supply because there's lots of glaciers in places like the Himalayas. And so they help provide some water resource stability to communities downstream. So in addition to sea level rise, water resource is really important. So getting a thorough understanding of our glaciers is really important to be doing right now when we're facing some uncertainty in what might happen in even some fairly near futures.
Yeah, I've thought about, a lot of people have heard of the biosphere, but I just realized after you saying that cryosphere is such a,
biosphere, cryosphere, atmosphere.
Yeah.
All of geoscience, we're really into all these different spheres. Yeah, it's a sphere-focused science. Yeah. Yeah.
As is physics, the spherical cow joke.
Oh,
yes.
yeah, it's all spheres in the
Yes,
end.
yes,
Yes.
yes.
In the end, and it's all pies, and then the universe is just a giant pie and spheres, and yeah. Anyways,
I'm gonna cut you off now,
Yeah,
Matt.
cut me off,
So-
please. Yes.
So, are there specific research questions that you're working on right now?
So, cryoseismology and the sort of broader field that it's in called environmental seismology, that's just sort of looking at seismic signals from non-earthquake sources. So you can also use seismology to look at rivers, to look at landslides, all kinds of things are making seismic signals. A lot of the big questions are, how is this going to be the best and most useful and most exact observational tool? Because the goal is to get something that will either tell us more about a system so we can understand it better, or give us the first notice of something happening in the system. So, for example, if you can detect glacial outburst floods, which is when a lake on top of a glacier can drain through and put a lot of water out the end of the glacier, that can be a flood hazard for people downstream. So if you can detect it seismically first, then you don't have to wait to watch more water coming out the end, and you can warn the people downstream more. Folks are also interested in that for landslides. One of my friends at Caltech has done some research on what do the seismic signals from landslides look like. Maybe if we can give just a few more minutes of warning to communities downhill, it could be really helpful. So it's about using seismology as a tool to help get better understanding of our environment in general and helping us see some things that we might not be able to see without very sensitive seismometers.
Like a secret decoder ring. You just have to, know, okay, here's the encoded message that comes from the seismometer. What does that tell us about what's going on elsewhere?
Yeah, that's kind of a lot of seismology is like that. It's decoding from squiggles to natural phenomenon.